syllabus start कर रहे हैं. So let's start. Okay. And reverse order we start. We'll do the organic one first. So starting with, I think this is the last question, question number 6. So the question is about just one second. So the question is, okay, there's an alkene and it reacts with H2 in the presence of an acid catalyst to form an alcohol with the molecular, name the type of reaction. So what type of reactions do alkenes undergo?
Addition.
Okay, and specifically that's electrophilic addition. Okay. So that's the first one. So then you've got can name the type of catalyst used in this. So when you want to add water, what's the conditions? What's the conditions bata do?
H3PO4 catalyst.
Okay, and what are the conditions? Sorry. So what are the conditions for this? Okay, hydration of alkenes.
300 degrees Celsius and 60 atmospheres.
60 atmosphere, so high pressures, high temperatures, and complete the table to show the number of sigma bonds and pi bonds present in both this thing and this one. So you would have to draw this one. C3H6 is how many double bonds, how many sigma bonds, and how many pi bonds does this have? Okay, every bond, whether there's a double. Okay, sigma bond, that's 1, 2, 3, 4, 5, 6, 7, and 8. Okay, every bond between atom has one sigma bond. And when you have a double bond, the rest of the bonds are pi bonds. So there's one pi bond. And then you have this other one, which is going to be an alcohol because water is going to get added to the double bond. So the major product would be, so can everyone else, I think everyone can hear me right now. So check your connection. Okay. So the other product is going to be that you'll have the major product would be, according to the Markovnikov's rule, the H will get added to the carbon that's already bonded to more H atoms, and the OH is going to be bonded over here. So you're not going to have any pi bond now because all of the bonds are single bonds. TK OH could be, I've drawn it as single bonds. So how many sigma bonds you got? You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. TK. So you've got 11 sigma bonds, and there are no pi bonds. The reaction of propene with H2O occurs in a two-step mechanism. In step 1, C3H6 reacts with H+1 to form a carbocation. Draw structures to identify the most stable and less stable carbocation, which can form in step 1. So what happens is that you will have a double bond, and the H+1 would be interested in the electrons of those double bonds. So it's going to get attracted. So it's going to be an electrophile that's going to be attracted to the double bond electrons. So the major product, the one that's more likely to be formed, is going to be this one, the more stable carbocation. The electrons in the double bond are going to leave the double bond, and they're going to be attracted by the H+1. So the positive charge on the H will go away. The carbon in the middle would become positively charged because electrons from that carbon in the double bond have been taken away by the H ion over here. And that's the carbocation that's going to be formed. The other one, the less stable one, would be the other one where where you're going to have the double bond again, but this time the H+1 is going to attract electrons from the double bond, and it will bond with the carbon on the left side, and this carbon will become a carbocation, and that's going to be a less stable one. And what's the explanation for this? Why is this more stable?
Because more alkyl groups are attached.
Because you have more alkyl groups, it's surrounded by large groups. So the explanation for this one is that this is a second degree carbocation, or you can say that it's a secondary carbocation. So it's got two carbon chains attached to it, one on the right side, one on the left side. So the carbon which is positively charged is right in the middle. So second degree carbocations are more stable. And why are they more stable? Because they have more electron donating alkyl chains. Donating alkyl chains. And what do? They decrease the charge density. Because it's surrounded by electrons, there are 9 electrons over here, 9 electrons on this side. So the positive charge is going to be somewhat neutralized. So the positive charge is going to be a lot smaller. So which decrease carbocation charge density? So hence the carbocation would be a lot stable. This one would be unstable because the positive charge is going to be much bigger in size. Why? Because this positive charge is going to be really big because it's not surrounded by large groups. You got 2 hydrogen atoms on one side, so they don't have any electrons. So the positive charge is not going to be neutralized that much because it's not surrounded by large groups. It's not surrounded by electrons. So the positive charge is going to be large. So what will happen is that this will be unstable. Who was taking electrons away from it? It was this hydrogen atom that was taking electrons away from it. It will not be able to take electrons away from it because the positive charge is going to be very big. So it would be very hard to form this carbocation because the electrons are going to be pulled back and the double bond would be reformed. It's very hard for the carbocation to form in the first place. So this carbocation, which has a large positive charge, is very hard to form because somebody has to pull electrons away from it, and that somebody was H, and that will not be able to pull electrons away from it because of the greater positive charge. So very less likely to form. This one is more likely to form. And remember this is coming very frequently in almost all any mechanism where the carbocation is formed, whether it's an SN1 mechanism or the electrophilic addition mechanism. You'll be asked about this. Now, name the major organic product formed from the reaction. So what is the name of this major organic product? What do you call this?
Two hydroxypropane.
It's an alcohol first thing. It's there is no other group
Propanol.
It's propanol. This is propanol. I mean, there is no other group in the molecule apart from the alcohol group. So the suffix would be the ol group. So it's propanol, and it was a saturated molecule. So you're going to have AN in the middle. As a 2-bromopropane reacts to form propene, hydrogen bromide, and water under certain conditions. Name the. I'll open the chart as well. Just 1 second. So this is, he's talking about halogenoalkane, and he's talking about elimination. He's talking about forming an alkene. Which is this part over here. That when you have a halogenoalkane, you react it with NaOH or KOH ethanolic plus heat, or concentrated NaOH or KOH ethanolic. The halogen leaves, and when the halogen leaves, you get a double bond. It forms an alkene. So this reaction over here, he's talking about 2-bromopropane. So name the type of reaction. That's elimination. I'll explain what the reaction is. 2-bromopropane. Propane is this one. 2-bromo means you got a bromine on the second one and you got all these H atoms. And so you got all these H atoms. Now the reaction that you're going to have is that the bromine is going to leave and the H from the neighboring carbon atom would leave as well. And that results in the formation of a double bond. It forms propene. So the reagents are NaOH or KOH ethanolic. I mean, ethanolic is, the reagent is basically NaOH. Ethanolic must be the condition. Plus you're going to heat it as well. So the solvent used is ethanol. Now move to the previous question number 5 now, which is what is meant by the term hydrocarbon? That's a molecule that contains hydrogen and carbon atoms only. That's a simple definition of what a hydrocarbon is. Name the raw material that is used to produce a sample of naphtha. So where do you get all the organic raw materials from?
Crude oil.
Okay, that's going to be crude oil or petroleum. Compound V is found in naphtha. It has a molecular formula of C10H22. By looking at the formula, you can tell that it's an alkane. It's a saturated molecule because it fits CnH2n plus 2. Now, when V is heated at a high pressure in the absence of air, an equal number of moles of ethene, propene, and W are made. So that is cracking happening. This molecule is breaking down. So the process is known as cracking. And they're talking about deduce the structure of W and draw its structure below. So what is W? First thing, C10H22 is breaking up. And he's saying that you're getting an equal number of moles of ethene. What is ethene? That's C2H4. And propene, which is C3H6. And there is W. So you already have 5 carbon atoms. So whatever W is going to have 5 carbon atoms. And you got 10 hydrogens. So this one will have 12 hydrogens. So that's going to be W. And W, they've told us that it's a straight chain saturated molecule. They've already told us there were many isomers of W possible, but it's a straight chain saturated molecule. So they're asking you to draw the structure. Remember, when they talk about the structure, that is the most general description of a formula. That is that any formula that shows structure, that's sufficient. You could draw a skeletal formula over here. You could draw a fully displayed formula. You could draw a condensed version. We'll go for a condensed version. So it's CH3, straight chain, CH2, CH2, and then CH3. So any formula that tells you the structure of the molecule. Now, propene is separated from the mixture and heated in air in the presence of the catalyst. Propene is oxidized to X, which contains 2 functional groups. So it's getting oxidized. Effervescence is seen when Na2CO3 is added to X. So I've got propene, which is this molecule over here. And there's some reaction that's happening that we don't know what that reaction is. We haven't studied that reaction, but it's getting oxidized. So you've got propene getting oxidized and there are 2 functional groups. So it's oxidized to 1 molecule actually, not 2. They're saying it just gets oxidized to X. And X reacts with Na2CO3. So who reacts with Na2CO3? What functional group does Na2CO3 reaction? Which functional group is confirmed by this?
Acid.
It's a carboxylic acid. Remember this, that only with carbonates, you only have, if I make this bigger. So with carboxylic acids, you got sodium carbonate reacting, and that would produce salt, water, and carbon dioxide. Alcohols only react with sodium, that's it. They don't react with anything else. So this one is is a carboxylic acid. Identify a reagent which could be used to show that X contains a acetyl bond C. Include a relevant observation. So how do you confirm an alkene? What is the test for identifying an alkene?
We add bromine
Okay, so
that decolorizes.
so you can add Br2 aqueous, and red brown bromine gets decolorized. So next one is about a polymer. And molecules of Y react together to form an additional polymer Z. The diagram shows the repeat unit of polymer Z. So you draw the structural formula of monomer of Y. So all you have to do is, whenever you have an addition polymer, all you have to do is get rid of the continuation bonds, and you got these two carbon atoms. So I'm going to draw the. So you got these two carbon atoms, and you got a carbon double bond O, and O minus 1 Na plus 1 on the top. There must have been an H, and another H, and another H. So this was what the formula was. Now to figure out the monomer, all you have to do is you have to get rid of the continuation bond and put a double bond back between the two carbon atoms, and that gives you your molecule. So that's the structural formula. Now polymer Z is useful because it absorbs a large amount of water. So this is absorbing a large amount of water. However, there are problems associated with the disposal of products containing polymer Z. Combustion is not an appropriate method to dispose of pure Z because the process. Identify a gas released during the combustion of Z which contributes to the enhanced greenhouse effect. So which gas is this?
Carbon dioxide.
Okay, so CO2 is a greenhouse gas. If that told you about a poisonous gas, that would have been carbon monoxide.
Monoxide.
So I think that's the identify which could be produced during the combustion, other than greenhouse of its release. So that's probably carbon monoxide, and the consequence for that is that it's a toxic gas, causes choking, and breathing problems. So the next one is the question is identify the oxidizing agent in this reaction and explain your reasoning with reference to the. So that's easy. The oxidizing agent is the one that get reduced. So in this case, it's going to be Br. They even gave you the oxidation state, so that made it even easier. So you're going to talk about Br going from 0 to -1, and you're going to say that it gains 1 electron. Suggest one change you would observe ignoring temperature when bromine reacts with methanoic acid. One change, so observation. What is one observation that you're going to observe in this particular reaction, which is fairly obvious? What's the observation? It's the same bromine question, which is that bromine gets used up. So the red, brown, or orange Br2 gets decolorized. As for next one, the reaction can be followed by measuring the concentration of bromine. Haji.
So due to double bond.
We don't know what's happening. We don't know nothing about this reaction. The only thing that we know about this reaction is that there's bromine, and that bromine will get used up, right? Is that clear?
Yes.
So आगे जाके खत्म हो जाएगा ना वो. So the red brown bromine will get finished. It's going to get decolorized, right?
Okay, sir.
I said use the graph to calculate the average rate of reaction during the first 600 seconds. State the units of this. Remember, you'll be asked about calculating the rate of reaction. And it's a very small thing, but what is the rate? Rate is when you measure any change with respect to time. It could be any change. It could be the gas volume changing with respect to time. It could be Technically, it's usually the concentration with respect to time, how the concentration changes. Sometimes the concentration is increasing, sometimes it's decreasing. But remember, it could be any change, mass could be changing. So it's always whenever you have a change versus time graph, I mean, the concentration is changing with respect to time. The gradient is the rate. The steepness of the graph tells you what the rate of the reaction is. So he's talking about the first 600 seconds. So use the graph to calculate the average rate. So we need the average rate. So what is the change in Y? So I think it's changing up till this point. So the concentration decreases from 100 to so what's the total change? 100 to 12, I guess. That's 12. So that's 88. So 100 into 10 per 5. And it changes all the way to 12 into 10 per 5. And divide by the time change, which is 600 seconds. And the rate would be change over time. So the unit would be mole per dm cube. So that's your y-axis. Divide by time, which is or over S or divide by S. So that's going to be your average rate. That's going to be your unit, and you can find what the answer is for this. Now the experiment is repeated at 40 centigrade, and this relatively small increase in temperature produces a large increase in the reaction rate. Sketch a graph on the axis to show the expected results when repeating the experiment at 40 centigrade. So it's repeated at a higher temperature. So what will happen that the gradient of the graph is going to be a lot steeper. So it's going to look like this. But it's going to end at the same point. Everything will end. I mean, you can make a better graph than this, but it's probably going to end at the same time. So that's just make it steeper. That's it. But it should end at the same point. You're not adding more of the reactants. So there should be the same amount of reactant or left at the end of the reaction. So the rate of the reaction increases when the frequency of successful
So can you show the graph again, please?
This one.
Yeah, okay, thank you.
But it should start and end at the same point, right? Because you're just changing temperature. So the amount is not changing, it's just happening quicker. So it's going to be steeper. Explain why an increase in temperature produces the effect. So if you have a higher temperature, what will happen is at a higher temperature, you'll have more kinetic energy. And since you'll have more kinetic energy, one second. And there are going to be more particles because you have to explain successful collisions as well. Having more kinetic energy, the particles would collide with each other with more frequency as well. But you'll also have more particles at a higher temperature, having the minimum. More particles have energy greater than the activation energy. Hence, you will have more frequent and successful collisions. Since you were being asked to discuss the frequency of successful collisions, that is linked with activation energy. So you had to make a comment on activation energy as well in this case. Because there are two things. One is frequency. The frequency of collisions can increase in many different ways. You can increase pressure, you can increase the concentration of the particles, they'll bump into each other with a lot more. But when you take it to a higher temperature, not only does the frequency increase, but the number of successful collisions or the proportion of successful collisions, they also increase because the particles are more energetic. So they're going to have, more of them will have activation energy now. The dotted cross showing the bonding in methylic acid, which is HC, double bond ON. So it's basically single bond over here, a double bond over here. So we'll make this oxygen with a shaded dot, and a single bond over here, oxygen again with a shaded bond, and we got a single bond over here as well. And then you draw the rest of the electrons for oxygen. Oxygen has a total of 6 electrons, so that's 2 lone pairs. So you got 2 lone pairs. अच्छा फिर ये कि this one as well. I think that's about it. Make sure you draw the remaining electrons as well. Carbon has 4 electrons, so all 4 of them are shared. Hydrogen just had 1 electron, so that is shared as well. So we are done with this question about rate, and this one, question number 3. Write an equation to represent the reaction of NaCl with concentrate sulfuric acid. So this is about the halide ions being good reducing agents. Remember, the bottom 2 are really good reducing agents. They like to lose electrons because iodine is a bigger atom. It's shielded. Its nucleus is shielded, so it's not very strongly attracting its outer electrons. So it very easily loses electrons, but Cl-1 does not. So the first reaction is simply a displacement reaction. What happens is that when you react NaCl with H2SO4, it's going to be cool. Let's think. So what happens is you get a displacement reaction. You get NaHSO4. And you got steamy fumes of HCl gas that are produced. So this over here is the reaction that Cl-1 does not like to lose electrons. So with NaCl, there is no redox reaction. It doesn't like to lose electrons. Instead, what happens is that the NaCl and H2SO4, all their ions, they get mixed up in water. And because the sulfuric acid is very concentrated, the H+1, they get attracted to the Cl-1 to form HCl gas, and they start forming fumes of HCl gas. And what is left in the solution is Na ions, H+1, and SO4-2. So you get a displacement reaction, which is NaSO4 is formed and HCl gases. But down the group, what happens is that Br-1 and I-1, they really like to lose electrons. So in that case, you do also have a displacement reaction, but Br-1 starts to lose electrons. It starts forming Br2, and sulfuric acid has to get reduced. Because if this is losing electrons, sulfur over here, which is +6, starts to gain electrons to form sulfur, which is +4. The same happens with I-1, where the redox part is a lot stronger. I-1 is a very good, extremely good reducing agent. So the sulfuric acid starts to get reduced to sulfur dioxide, H2S, and sulfur. So the reduction is a lot more in the case of NaI. So this question is all about this one. It's name the type of reaction. That's a displacement reaction, not a redox reaction. And the other one is identify the chemical responsible for the steamy fumes. When you do it with NaI, the steamy fumes are produced by HI, which is, so you're going to get the same displacement reaction initially. That NaI reacts with H2SO4. The H plus 1 and I minus 1 would combine to form HI, which is the steamy gas that's produced. But immediately there's going to be a lot of I minus 1 would start to lose electrons to form iodine. So the reaction of NaI with concentrated sulfuric acid continues, forming several other products, including a dark gray solid. That is definitely iodine. Identify the chemical responsible for the dark gray solid and one other product of the reaction. So what are your other products? The other products are your sulfur products. So you're going to have sulfur and H2S. And explain, you just have to identify one. Explain the difference in observations at room temperature when NaI reacts with sulfuric acid compared to NaCl. So what is we don't have to
Sir,
explain.
the other product could be sulfur dioxide as well.
I say इस case में ना the usually what happens in the market scheme is I've actually cut out sulfur dioxide as well over here. The reason is that it is formed, but since I minus 1 is a much better reducing agent, so the sulfur usually gets reduced very strongly. So sulfur goes from +6 to 0. It also goes to -2. Rarely does it go to +4. I mean, that is formed, but trace amounts, not, I mean, this reaction will not happen that much. So if they are looking for one product, go for these two. Is that clear?
Okay.
Either be, I'll just add it over here. So this one is, it is possible. But since the reduction is so strong that you usually get H2S and sulfur, which is a yellow solid. H2S has this smell, has a pungent smell. As I explain the difference, now you don't have to talk about the observation, you have to explain it. So you're going to explain it using the whole thing about iodide ions being a really good reducing agents compared to Cl-1. So they are better reducing agents compared to Cl-1. So what happens is that because you have to explain the observation, you have to explain that I-1 gets oxidized to I2, forming the gray solid. And the other one does not. Cl-1 is not oxidized. Complete the equation for the reaction of Br-1 with concentrated sulfuric acid at room temperature. So what is produced is Br2. The sulfuric acid gets reduced to sulfur dioxide, and you'll have water as well. Now the tricky part is balancing the redox equation. You have to balance the number of electrons. Either you remember it, if you memorize this properly, if you memorize all of the inorganic parts, where's the inorganic part? Either you memorize this equation, that this is the equation, or you should know how to balance this equation. Although this is not that difficult, but make sure that sulfur is +6. Over here, sulfur is +6 or +4. The electrons gain and loss must be equal. So it's gaining 2 electrons. Br-1 goes to 0. So it's -1 over here. And it's 0 over here. So it's lost 1 electron. So the electrons gain and loss must be equal. So this should be multiplied by 2, and this must be multiplied by 1. So you should have 1 sulfur and 2 Br-1s. And when you try to balance this, so these two things are already balanced now. The only thing you got to balance now is the oxygen. So 4 over here. So this should be multiplied by 2. And in that way, I think there should be 2 H+1s over here. Okay, but make sure whenever you balance a redox equation, the electrons gain and loss, they have to be equal. Although this wasn't that difficult a question, but you can either memorize the inorganic equations or make sure when it comes to redox, always balance the number of electrons that are gained and lost. So let's say we have
Sir,
so
उसको
this
दोबारा explain कर दें, please. I don't get how if it's +2, then how
which
for the
one this
sulfur
one.
part. Yeah, the sulfur part.
So I'll do another sulfur part, right? Sulfur is +6, right?
Yeah.
But you can calculate the oxidation state. Sulfur is +6, right? Over here, sulfur is +4, right?
+4.
So that means it's gaining how many electrons? Sulfur is gaining 2 electrons, right?
Right, it gains 2 electrons. Yeah.
And Br is -1, and Br over here is 0. So that means it lost how many electrons? It lost 1 electron, right?
Yes.
So if that is gaining 2 electrons and this is losing 1 electron, the amount of electrons gained and the amount of electrons lost should be equal, right? So I'm going to multiply it by 2.
2. Okay.
So that means Br -1. Now this was easy. I'll talk about this other one. This would be harder, like the iodine one. Let's
So
talk
what
about
the hydrogen then?
Actually, the electrons gained and lost has nothing to do with hydrogen, because hydrogen is not gaining or losing electrons, right?
Right.
I mean, hydrogen is H+1 over there. Hydrogen is still H+1, so that has nothing to do with redox. Hydrogen is balanced the old-fashioned way. Like once you sort out the electrons gained and lost, the next thing that you're going to do is you're going to balance the hydrogen in the normal way. Okay, kya kiya tha? There were 4 oxygens, right? And even oxygen, I don't care about oxygen, because
Yes,
oxygen is -2, oxygen is -2, oxygen is -2. So oxygen is not part of the redox reaction. So you just balance it the normal way. You got 4 oxygens, 2 over here. There should be 2 over here as well, right? I'll do a more difficult one. Like, let's say they ask you to make this equation. Let's talk about HI reacting to form sulfur plus H2O, right? That would be slightly harder to balance. So you got HI reacting with H2SO4, and they're saying that it forms a I2, and it forms a sulfur plus H2O, right? Now, you can't balance the redox equation in the normal way. You have to make the electrons gain and lost equal. So this is +6, right? And sulfur over here is 0. So that means how many electrons are gained? That's a total of 6 electrons, right? Clear?
Yes.
And I is -1 and I over here is 0. So that means if you look at this, that's a loss of 1 electron. So the next thing is you balance the number of electrons that are gained and lost. So I'm going to multiply iodine by 6, right? And sulfurs, I'm going to multiply it by 1. That means I'm going to keep it as 1 sulfur, right? So there should be 6 iodines over here, and there should be 3 I2s over here, so that I can have 6 iodines, right? Is that clear?
Yes, sir.
And sulfur is going to be multiplied by 1. So I'll have 1 sulfur over here and 1 sulfur over here. So that's, I don't need to multiply it with anything. The last thing would be, I would go for I would balance this thing, the last thing that I didn't balance. And that's, so I got 4 oxygens, so there should be 4 water molecules over here. Is that clear?
Yes, sir. Thank you.
So next is you've got this question, which is that state one similarity and one difference in the way the atoms in a carbon monoxide are bonded compared to the atoms in a nitrogen molecule. So one similarity and one difference. The similarity is they've got triple bonds. So that's the similarity. I said they both have triple bonds. That's the similarity. The difference is that this one has one dative bond. So one dative covalent bond and one coordinate bond. Because both electrons are being shared by oxygen. Yes, by oxygen. So that is the main difference. That's niche. Use the electronegativity values and relevant details from the data booklet to complete the table. The number of electrons per molecule. The number of electrons per molecule, that's nitrogen has 7, the other nitrogen has 7, that's 14 electrons. The number of electrons in the carbon monoxide molecule, carbon has 6 and oxygen has 8. So that is also 14 electrons. The type of intermolecular force that it's going to have. Nitrogen is going to be polar or non-polar?
Non-polar.
It's going to be non-polar. So it's just going to have van der Waals forces. Or you can say temporary dipole, induced dipole forces, and the other one, carbon monoxide, that's going to be polar because you can look at the electronegativity difference. Oxygen is a lot more electronegative. So the electrons will be closer to oxygen and the electrons will be further away from carbon. So that's going to have permanent dipoles. And N2 is less reactive than CO, even though N2 has a lower bond energy. Carbon monoxide has a much stronger bond compared to N triple bond N. So why is CO more reactive? The reason is that whenever you have a polar molecule attracts other molecules. So it attracts.
So CO में 14 electrons है.
Okay. Carbon has 6. I mean, you don't have to draw the structures. Just remember, carbon has 6 and oxygen has 8 electrons, right?
Okay.
Bonded
Can you
differently,
say that
obviously.
it has a dative bond, so it is less stable?
Listen, dative bond and covalent bond, there's no difference. Like when a molecule forms a dative bond, right? There's
But nitrogen
absolutely
has triple covalent bond that is strong enough.
carbon monoxide is stronger. What data booklet and bond is, they both look exactly the same.
All right.
Except this is what N2 looks like. So they both look exactly the same. Lone pair, iska bhi lone pair. And this one as well. Remember when जब दो atoms के बीच में there are electrons, right? They don't know किसके electrons है. उन्हें तो नहीं पता कि there's a dot and there's a cross, right? For them, the electrons are exactly the same, right? Except for the fact that this one is disbalanced. Oxygen is more electronegative. It's got a stronger nuclear charge, so the electrons are slightly closer to oxygen, which makes this side slide negative, this side slide positive. Wahan pe the electrons are right in the middle. They're equally distributed. So that's the only difference. So that and even though this bond is stronger, if you look at the bond energy table, this bond is actually strong. It's harder to believe this one. But this one is more reactive. The reason is it attracts other molecules. It's because the negative side, that's going to attract the positive side of some other molecules. So polar molecule, they attract other molecules. While N2 has a very weak intermolecular force, it doesn't really attract other molecules. It's just got van der Waals forces. Where carbon monoxide and nitrogen are gases at room temperature and pressure, they both behave like ideal gases. State the two conditions necessary for a gas to. When does a gas approach ideal gas behavior? Under what conditions?
High temperature and low pressure.
So it's going to be high temperature and low pressure. And the reason for that, the reason is if they ask you to, remember, make sure you understand this. When they tell you to state, you just state it, you don't explain it. When they ask you to explain, then you have to sort of take a deep dive into it and you have to explain the whole thing. But if they had written state and explain, so higher temperature, the molecules are energetic and they can easily break the intermolecular forces. So they would behave as a gas. The particles would be freely moving around in all directions, behaving like a gas. And at low pressure, they've got big gaps. At low pressure, the volume increases. So the particles are really far away. So you can say two things about low pressure. One is that since the particles at low pressure would be so far away from each other that the intermolecular forces would become negligible and the particles would be moving freely. Or the other one would be that at low pressure, the gases will have a lot of gas. So the particle volume will be negligible compared to the volume or the total volume that's occupied by the gas. Or you can say that the gas becomes is very easily compressible because it's going to have so many gaps in it. So explain why N2 behaves more like an ideal gas than CO. So why is N2 more ideal than CO? What's the one major difference?
The attraction between the molecules.
Because it's a polar molecule, right? So N2 is less likely to behave as a N2 is more likely to behave as an ideal gas because it's got van der Waals forces. So it's going to have weaker intermolecular forces. Particles would be attracting each other. So in gases, the particles should be freely moving around, not getting attracted to one another. So it's going to have weaker intermolecular forces, which is why it's going to behave more and more ideally. And you can talk about carbon monoxide having a stronger intermolecular force. Calculate the amount in moles of pure nitrogen which occupies. So this is about PV0 to nRT. All you have to care about when you're doing a PV0 to nRT question is the units. The rest is kind of, so you have to calculate the moles PV0 to nRT. So basically it's PV divided by RT. So pressure has to be in pascals. So it's going to be 101 into 10 to the power 3 pascals. The volume must be in meter cube. So how do you convert centimeter cube into meter cube? You multiply it by what? How do you convert cm cube to
10 to
meter
the
cube?
power of -6.
Yeah, that's 10 to the power -6 meter cube. And the whole thing gets divided by R, and that's 8.31. And temperature must be in Kelvins. So what is 20 centigrade in Kelvins?
293.
Yeah, that's 293. You could correct me there. Make sure practice your calculators as well, because that would be very important as well. Try and find what the answer is. You get all kinds of silly mistakes will happen on your calculator. You can be very careful with your calculators.
4.15 times 10 to the power -3.
Is that 4.1?
15.
15 times 10 power
-3.
3 moles, right? And that kind of looks within range, within possible ranges. Now, and also remember, be careful about significant figures. Like this is 3 significant figures, 3 significant figures. So your answer should be, they haven't told you, but this should be 3 significant figures as well. Now, are we done with this one? I think we're done. So coming back to the first question now. What is meant by the
Excuse
term?
me, sir.
Hanji.
We were supposed to divide, not multiply the volume. Because my answer is like 4.1 into 10 to the power -13 if we multiply.
You have to divide the volume?
Yes, because it's cm, we have to convert it into.
So into 10 to the power -6 kiya na? -6, that is division. -6 है ना?
All right.
ठीक है. और यही आएगा, but make sure it's going to be 100 divided by 1 million, right?
Yes.
वो into 10 to the power -6 होगा, ठीक है? So लेकिन देख लो, ठीक है? Make sure you know how to do this on your calculator. अच्छा, last question. We have what is meant by the term relative molecular mass? So that's the average mass, because a molecule is going to have many isotopes, so its mass would vary. So it's the average mass of a molecule compared to 1/12 the mass of a carbon-12 isotope. Of C12 isotope. So that is the relative molecular mass. Now, use what's the empirical formula of this thing? That's easy. That's CHO2. Calculate how many carbons are present in 0.18 grams of this thing. First thing is I'm going to find out what the moles are. So I'm how do you find moles of this thing? I should make sure you show your working as clearly as possible. Don't present your answers in a decent way. So moles is mass divided by MR, so it's 0.18 divided by the MR of this thing is, I think, 2 oxygens 32 plus 1, that's 33 plus 12, that's 45, and this is also 45, that's 90. So divide that by 90. How many moles do you get for this? It's what's 0.18 divided by 90? Did anyone try this?
0.002.
So you're getting 0.002 moles, right?
2.
So,
Yeah.
so I've got this molecule now. Now one molecule has how many carbon atoms? It's got 2 carbon atoms, right? One molecule has, so the ratio is 1:2, right? So it's got 1:2. One molecule has 2 carbon atoms, or I can simply just write C over here. Okay, so one molecule has 2 carbon atoms. So if I have 0.002 moles, I'm going to have how many carbon atoms? It's going to be 0.004 moles, right? And the final answer is, I think it should not be in moles because they're just asking for how many atoms. So the final answer is you have to convert that into the actual number, which is like if you just multiply it by the Avogadro's number, that's going to be 0.602 times 10 power 23. So what do we get for that? At a 2 times 10 power. It shouldn't be 2 times 10 power minus 3. Remember your accuracy. This is 2 significant figure. At least give a 2 significant figure accurate answer. So it's going to be 2.4. I think 2.4 would be sufficient. Even though you're getting 2.408 something.
408.
They can make sure if your actual value that you're using is accurate up till 2 significant figures, you don't know what the third number is. You don't know whether this is 0.181 or 0.180. You have no idea what the third number is. So in your final answer, the third number would be doubtful. So it's going to be 2.4 into 10 power. 10 power 21.
Yes, sir.
Okay, so be careful with the significant figures that you use. Now the next part is you've got construct an equation. So let's do this quickly. Last 3 parts to represent the reaction of when heated. So you're heating this one CaC2O4, and what is happening? It breaks down to form calcium oxide, carbon dioxide, and carbon monoxide. So calcium oxide, carbon dioxide, and carbon monoxide. So is this already balanced? That's CaO. The oxygen is 3 plus 1, that's 4. So I think that looks balanced. Identify the type of reaction which occurs when this thing is heated. So that's I guess decomposition. You can even go for a redox reaction because I think it's a redox reaction. Carbon has a different oxidation state over here. Carbon has a different oxidation state over here as well. So disproportionation when the same element goes into 2 different oxidation states, gets reduced and oxidized. Actually, identify another compound containing calcium ions, which will also produce carbon dioxide. So that's the decomposition of carbonates. That carbonates would do that. So they will also produce calcium oxide when heated. So that's the last one. Yes.
Sir, for question 1.3. 1.3. Yes, sir. Yeah. No, 1.13. Point A, sorry. yeah, for the moles thing. So you said that how can there be like 0.004 moles in 0.002 moles?
So the moles, this was 0.002 moles, right? If
Yes, sir.
you what's the ratio? If you have one molecule, how many carbons do you have? You've got 2 carbons, right?
Yes,
अगर मेरे पास 50 molecules होते तो carbons कितने होते? That would have been 100, right?
100. Yeah,
So if I have 0.002 moles of this molecule, the amount of moles of carbon is going to be double that amount, right?
right. But how can 0.0, how can like the double amount of moles be in only one molecule? Because we calculated the
Maybe it's
moles of the molecule.
let's say I say there's one car, right? So how many tires does one car have?
4.
ज़्यादा है ना, मतलब does it make sense now?
Right. Okay.
मतलब वो एक चीज के अंदर बहुत सारी चीजें हो सकती है ना, मतलब it's if there's
Yeah, I
one
get what
bus,
you mean. Yeah.
ठीक है. So there's one
Yeah.
molecule, but inside that molecule there are 2 carbon atoms, right?
Right.
इसलिए वो रेशियो है. This is all ratios. It's not के इसलिए वो कभी भी मोल्स दोनों साइड पे इक्वल नहीं होते ना.
Yes, sir. I get. Okay. Thank you.
चलो ठीक. Okay everyone, take care.
Okay, sir. Allah.
Love.
और ईद मुबारक. अल्लाह हाफिज.